Hi, I'm Mr. McConley, and this is BKW General Physics class. And today we're going to talk about the acceleration of gravity when you drop an object. And we're going to try to figure out or calculate the acceleration of gravity by dropping, in this case, we're going to use a tennis ball. So, let's go over here, and I want to point out some things first. So if you can focus in on this piece of paper. The first thing is, this is just to help you out because I know many of you wouldn't have meter sticks at home. So we're going to talk about if you drop it from a meter, you're dropping it 39¼ inches. If you drop it from 1.5 meters, if you back up a little bit, you can get rid of your shadow. 1.5 meters, then it's 59 inches. And if you drop it 2 meters, it's 79 inches. So in this case, for what I have set up down here in the basement, I'm going to drop it 2 meters or 79 inches. And I've put a mark over here on the wall measuring 79 inches from the floor to this mark right here. That'll allow us to figure out what we're doing in a minute. So let me give you a little bit of background here to start us out. The equation we're going to be basing this off of is this equation, which you might not be familiar with. D is VIT plus 1/2 GT squared. It's a mechanics equation. Now in this case, the initial velocity when I let go is 0 because I'm letting it go and it's starting from rest. So that's going to make this whole term go away because anything times 0 is 0. So I'm left with D equals 1/2 GT squared. Now remember, the point of this little lab we're going to do is to figure out what is gravity. So I multiply both sides by 2. That gives me 2D equals GT squared. And then I divide by G. Sorry, I'm trying to find G. I divide by T squared. Change my mind there. I divide by T squared, and I would get 2D over T squared. So this is going to be my working equation. And in this case, the distance that I'm going to plug in there is the 79 inches. But you wouldn't want to put in inches in these equations because these equations are set up for metric. So no, I'm going to put it in as 2 meters. And the time is going to be the average time of a few of my trials. So let's collect some data and we'll get some average times. See what we got. Let's try it out. All right, so I got my stopwatch here, and I'm going to do my best to drop from this height. And since I'm dropping it, I should be pretty accurate about hitting the start and the stop button on my stopwatch. So start, stop. All right, that was 0.62. So I go back over here, and I'm going to record these times. I'll just do a few to see if I'm being consistent. Do another one. Okay. That was pretty close at 0.59 seconds. Do the last one. Now in the case of the lab that you're going to be performing, I'm going to actually send it out to you on the next lesson that I put out on Google Classroom, and I'm going to ask you to drop it 10 times. That's just so you get a good average, so that the highs and the lows kind of get averaged out. So I'm just going to do 3 right now for the sake of making a shorter video. All right, and 0.61 seconds. All right, so what do? Well, I add them up, and then I divide by 3 because I have 3 in this case, but when you would be doing it, you'd be adding up and dividing by 10. So I got 0.62 plus 0.59 plus 0.61 equals 1.82 divided by 3. So my average time turns out to be 0.61 seconds. And it's 0.60666, so I rounded that to 0.61. So at this point, we could plug in and see what we got on our equation. So we got 2 times 2 meters, that's how high we dropped it from, over 0.61 seconds squared. So I'm going to do the 0.61 squared. So on the bottom I have a 0.3721 and seconds squared. And on top I got 4 meters. So what is 4 divided by 0.3721? Well, not terrible, not awesome. So a little information here, because you'll need this for your lab also. The acceleration of gravity, the ideal, the actual, what it really should be is 9.81 meters per second squared. This is your accepted value. Now I got 10.7, and there's a lot of reasons maybe for that. One reason I think that comes to mind is that it's pretty hard to, it's happening quick, so it's pretty hard to hit the start and then hit the stop right as it hits the floor and be very accurate about that. And if I'm off by a couple tenths of a second, that's going to be, make all the difference in the world, and it might totally change my outcome. The other thing is, since this is such a short distance, any little error I make is exaggerated. So what I would suggest when you try this lab out for yourself, I would suggest that you actually drop it from a higher height if you can. So maybe go outside, stand up on a porch or somewhere you can get more elevation. And when you drop it from a higher height, you'll get better results most likely. So I think that's all you need to know in order to do this. Basically, if you watch this video along with the information that will be given on the sheet coming out on Google Classroom, you should be able to figure out how to get the acceleration of gravity. So make sure you get back to me and show me what you got. For today, I'm Mr. McConley, BKW General Physics.